Hi, I'm Guang, 50 years old. In this lesson, we have the techniques and applications of definite integration, where we learn different methods that we can use to solve definite integrations. And for now, more specifically, double integration questions, alright? And for this double integration question we have here, we have modulus xy minus 1 over 4 modulus d sigma. And this integration is done over x greater or smaller than 0, smaller equals to 1, and y greater or equals to 0, smaller equals to 1. So firstly, can you imagine this boundary? So this boundary, it should be rather simple to imagine. Since for your x and your y, you would have x from 0 to 1, y is from 0 to 1. So 1 and let's say 1. Alright? So that means we would have pretty much a square. Right. So this is pretty much the area that we will have. But you have to be aware. You have a modulus here. And when you have a modulus, you have to be aware to separate them into positive or negative. Since if you have a negative inside here, you will need another negative to make it the positive for your modulus. Right. So which parts of it would exactly be negative? Which parts of it would be positive? Now, how about we let that be 0? So 0, if we make a little change, it will either go to the positive side or the negative side, alright? So when you let that be equal to 0, xy is equal to 1 over 4. So when xy is equal to 1 over 4, y is equal to 1 over 4x, and that graph will pretty much look like this, alright? So this is y is equal to 1 over 4x, and there is no going back upwards. Alright. So this is the graph we will be taking a look at. And that means we'll be separating it into two different regions. One here and one here. Okay? So these are the two different regions we will look at. So which one is positive? Which one is negative? Now, this region to the left side of the graph will be negative. The region to the right side would be positive. Right. It sounds simple, right? Now, we will take a look at these parts. How about we integrate with respect to x first? Or y first. It's all up to you. So if you want to integrate with respect to x first, that means you would have to change this into x is equal to 1 over 4y. Alright, so you can choose either one depending on your choice. So now we can change this into just a bracket. And let's say we have dx dy. So dx, we take a look at the positive part, so that's why you have a positive there. We will be having, so from the curve to your straight line, and this curve is 1 over 4y. 1 over 4y to x is equal to 1. Alright, so that is your boundary for x. Let's take a look at y. Y, that means we have to go from this bottommost part to the top. The top is obviously 1. But what is this bottom part? Now this bottom part, you will have x is equal to 1. So when you put that into either of these, you would get y is equal to 1 over 4. Alright? So that will be your positive region. Now we will take a look at the rest. And if you realize the rest, you would also have to take a look at it from two different perspectives, alright? So from two different perspectives. Why do you have to take a look at it from two different perspectives? You will realize one part of it will go from a straight line to a straight line, or the rest will go from, or should I say, a straight line to a straight line, or a straight line to the curve. Alright? Since both of these are negative, so you have to minus. So that means we would have to make a division over here. Or let me just make this division clearer. Alright, so that is the division that you would have to make, since from straight line to a curve, or from straight line to a straight line. Let's take a look at this. How about we look at from the straight line to the curve first. So we have xy minus 1 over 4 dx dy. So from your straight line to your curve, what will you have? That would be from 0 to 1 over 4y. And your range for y would actually be the same as the previous part, from 1 over 4 to 1, since they're pretty much the same. Now, for your last part, well, you will have your x is actually from 0 to 1. Right. Now, how about your boundary for y? Your boundary for y would be this range, which is from 0 to 1 over 4. Right. So this, or these, are the integrations that we would have to solve. We take a look at it first. Well, the integration should be rather simple, shouldn't it? So half x squared y minus 1 over 4 x, 1 over 4 x, and substitute in the values x is equal to 1 over 4 y and x is equal to 1, and then dy. For the second part, pretty much do the same things. So half x squared y minus 1 over 4 x, and then you have to substitute in the values x is equal to 0, x is equal to 1 over 4 y, and then dy. Alright, okay, so minus, integrate from 0 to 1 over 4, half x squared y minus 1 over 4 x, substitute in the values x is equal to 0 and x is equal to 1, then dy. Right, so these will be the three parts that we'll take a look at. Now, of course, if you realize the first two terms, well, you can choose to combine them, you can choose not to, it's up to you. So you will be seeing integrate from 1 over 4 to 1. Now, your first term, 1, so that means you'll have half y. So half y minus 1 over, so 4 squared times 2, so 1 over 32y, and then this part which is minus 1 over 4, and these two which will give you plus 1 over 16y. Now for the second term, you will have 1 over 32y, and then you put this in, which is a 0, then you have minus 1 over 16y dy, and then minus integrate from 0 to 1 over 4. You put in x, you have half y minus 1 over 4, and of course 0 just be 0. Right, so these are the terms you will be looking at. Now, I did say something about you could kind of combine some parts of it, isn't it? So, right, so let's take a look at how we could combine some of these different things. So integrate from 1 over 4 to 1. Now if you combine the first two terms, you have half y, then you have minus 1 over 32y minus 1 over 32y plus 1 over 16y, which is a 0. So you just have this, which is plus 1 over 16y and minus 1 over 4. Then dy. So for the part behind, you could choose to integrate it already, or you can choose not to. It depends on you. Now half y, it becomes 1 over 4y square, which you have 0 to 1 over 4. And then add 1 over 4y, and you have to substitute in the values 0 to 1 over 4. Next, we take a look at your differentiation for your first part. Now, in your first part, you'll have 1 over 4y square, substituting the values 1 over 4 and 1. And then add on 1 over 16 ln y, substituting the values 1 over 4 and 1. Then minus 1 over 4y, the values 1 over 4 and 1. Well, for the parts behind, you will have minus 1 over 64, 0, plus 1 over 16. Right, so these will be what you have to find. Next, you'll have to substitute in the values, where you have 1 over 4 minus 1 over 64. Well, ln 1 is 0, then minus ln 1 over 4. Well, ln 1 over 4 is ln 1 minus ln 4, which becomes a plus ln 4, where you have plus 1 over 8 ln 2. Then minus 1 over 4 plus 1 over 16. Alright, so this is the thing we will be dealing with. Alright, so 1 over 8 ln 2 would basically remain the same. 1 over 4 minus 1 over 4, they will cancel out. So you'll be having a 1 over 8 minus 1 over 32, which is a plus 3 over 32, right? Since 1 over 8 minus 1 over 32. Right, so this is the answer that you will be seeing, which is 1 over 8 ln 2 plus 3 over 32. Now, this seems like a rather complicated question. So let's break it down step by step, right? In the beginning, you draw out whatever region it could seem like. And in this case, you do have pretty much a square. And this square, you have to be aware, since in your integrand there is a modulus, and within the range of this modulus there are positive values and negative values, and these values you would have to look at them case by case. And so you separated them into at first 2 different integrations, but then you would realize that this you have to separate them even more, since the boundaries are again different. So you separated them into 3 different integrations, and with each of these 3 integrations you integrate with respect to x in this case, or you could also integrate with respect to y. Well, it just depends on whatever you like. And then after a series of integrations and simplifications, you will arrive at your final answer. Alright, so that is pretty much your entire thought process for this question. I hope that you can understand the entire question so far. We end it here, and thank you for your watching.